So good evening everyone and welcome to this lecture. We are into gravitational field. In the previous class we had seen some questions where we had calculated the gravitational field due to various type of charges. Yes or no? Do we remember those questions? Where we had found out the gravitational field due to various type of charge distribution. And today in this class we will and move ahead on the same topic. Now before moving ahead, there is one question again. You remember, you must understand that you must understand that there would be a repetition of these questions in the chapter on electrostatics. So I'll just take one question because I just wanted to take it, and this is the one. So I'll give you 2 minutes to solve this question. What has happened here is a solid sphere of lead has a mass m and radius r. A spherical hole has been dug out from it. See the figure. So there is a hole in this, and I think I have given you the concept of how to do questions with hole, whether it was question on center of mass or whether it was question on the moment of inertia. Do we remember that concept? Yes or no? Anyone remembers how I asked you to find out the center of mass of hole or moment of inertia of disk with hole? Do you remember that?
Yes, sir.
Okay. Well, you remember it or not? Basically, this is the question that you have to solve. So basically, the entire sphere was having a mass m, radius r. A hole is dug out whose radius is r by 2. You have to find out the gravitational field. No, not gravitational field. Gravitational force on this body of mass small m, which is kept at a distance of small r from the center of the sphere. I'll give you 2 minutes to solve it. I hope you are able to do this by whatever you know. 2 minutes. Tell me what are you trying, beta? I mean, I've given you enough time. 10 minutes. It's more than enough. If you can't do it in that time, I mean, it's not possible for you to do it anyways. Tell me what were you trying? How were you trying to do it? Any ideas, or you were just playing akkad bakkad Bombay wo assi nabbe pure so? But then there is nothing to play here because there are no options. What were you trying? Yes, please tell me. Was there anything that you were trying? That okay, this question can be done in this way or that way? Or it was just akkad bakkad Bombay wo? Huh? What were you trying? How were you attempting to solve this question? Yes.
Sir, I have done that gravitational field due to the whole sphere without the hole, and
Yeah.
gravitational field I have subtracted gravitational field due to the sphere which is a radius of r by 2.
Okay, good. So what is the answer that you get?
Gm into r minus 4 by r square something.
Okay, so I think the concept was correct. You take the first sphere as the original sphere. The original sphere has a mass m, radius r. The gravitational field due to this red sphere would be in this direction. Yes or no? So you find out the value of this gravitational field. Let me call it as G1. What is the value of this G1? It is in the G m by small r square. Yes or no? Yes or no?
Yes, sir.
Then you superimpose a negative mass whose radius is r by 2. So what will be the mass in terms of the original mass? Radius is r by 2, so volume becomes 1 by 8. So the mass becomes m by 8. Yes or no? Now the gravitational field created by this mass would be going in this direction. Yes or no?
Yes, sir.
So what is the value of this G2? G into m by 8 is the mass divided by the distance of this from the center of this. How much is the distance from the center of this? This r minus r by 2. Yes or no?
Yes, sir.
So that is the value of your this field r. Since r is not given in terms of capital R, therefore the answer looks a bit different. What is the net field? Net field is G net. That will be equal to G1 minus G2. Yes or no?
Yes, sir.
That is the answer, my dear friends. So your G net becomes, you can take Gm outside and 1 by r square minus 1 by 8 r minus r by 2 square. That is the answer, my dear friends. That is the answer. As simple as this. Do we understand this, or this has gone above what it's saying bye bye? I am going, don't worry about me. Huh?
Yes, sir.
What, yes, sir?
We understood, sir.
So any question that comes where you have a hole, this is the way you do it. You first consider it without the hole, and then you put a negative mass or a negative charge or whatever it is, like this. Do we understand this? Yes or no?
Yes, sir.
This is all about gravitational field that we will do, because the same thing is going to come many times in the electrostatic wala chapter. So we will call it a day here. Then I will move on to the next heading. Since we are dealing with gravitational field, this is the time that we can deal with gravity. What is gravity? Now we have devised this term gravity, and this gravity stands for gravitational force of Earth. Do we understand this?
Yes, sir.
This gravity is nothing but this gravitational force of Earth. The gravitational force exerted by Earth on smaller bodies like us, bodies which are of very small size compared to Earth, is known as gravity. Do we understand this? Yes or no?
Yes, sir.
Now, as soon as you understand this gravity, which is the force of gravitation, for any body which is nearer to Earth, what will be the force of gravitational? The gravitation force or gravity force would be G into capital M into small m divided by the radius of Earth square if the body is on the surface of the Earth or very near to Earth. Yes or no?
Yes, sir.
That will be the gravitational force. You can find out the gravitational field on the surface of Earth, and you can call it as Gm by r square. This G is actually the gravitational field on the surface of Earth, but you can also call it what? You can also call it acceleration due to gravity. Yes or no? So this is the value of your acceleration due to gravity, which is nothing but the gravitational field on the surface of Earth, and this becomes the formula for acceleration due to gravity on the surface of Earth, and the value of this comes as 9.8 meter per second square on poles and the surface of Earth. Do we understand this, or this is going above and saying bye bye, sir? Bye bye, I'm going, bye bye. Do you understand this? You can write this formula in this way also. GR square is capital G into capital M. Are we understanding this?
Yes, sir.
This gravitational field due to Earth. This gravitational field due to Earth is now known as acceleration due to gravity. Now you can write this formula in different ways. You can write this formula in the form of density of Earth. And the more the number of ways in which you can remember them. Do not wait for this question to come in the exam. Before exam, prepare it how you can write G in terms of density of earth. So you must now remember it, that I can write it like this: 4 by 3 pi G into RE. RE means radius of earth into rho. That means if the density is constant, G is proportional to the radius of earth or the radius of the planet. If they are comparing the acceleration due to gravity due to two planets, and this type of question come a lot, is directly proportional to radius. Do we understand this? Yes or no? Do we understand this? Yes or no? I hope you are noting it down, everyone. Then the second point, I'll give you all the points, then you note down them together. Then the second point, these type of questions are very important and coming. If mass is constant, then you can say, please note it down. Please understand it first, then you note it down. I'll give you time to note it down. First, understand it. Then acceleration due to gravity will be inversely proportional to radius square if mass is constant. If density is constant, it is directly proportional to radius. Now, sometimes they ask you, what is the percentage variation in G up to 5%? How does it vary with the change in radius? So now you can use the derivative form and you can get this revolutionary answer. Remember, all these are questions that are going to come in your exam. So first, understand them. I'll give you time for you to write them. Don't worry. These type of questions may come in error wala chapter, they might come in gravitation. Doesn't matter, the concept remains same. This was the formula when mass was constant. If the mass is not constant, mass and radius both change, then the formula for change in gravity will look like this. This is coming from the chapter errors and measurement. Do we understand this? Yes or no? Note them down. Note them down. All these are potential questions. I am giving you time. Just one more thing is left. So now you can bifurcate this formula. If radius is constant, the formula looks like this. If the mass is constant, the formula looks like this. So this is the complete analysis of what is there. Do we understand this, everyone? Let us go on above. We're saying bye bye, bye bye, bye bye. I'm going. Don't worry about me. Bye bye. Okay, now I'll give you 2 minutes. Note it down carefully. Do not make a mistake. Then let's move ahead. We have seen the formula for G. Now there are a couple of questions. Remember, these are the type of questions that you are more likely to face or encounter in an exam. So do it fast. If you can do it fast enough, I will give you more. If you can't do it, I will do one or two and we'll move ahead. So this is the first question. Acceleration due to gravity on moon is 1/6 of the acceleration due to gravity on earth. If the ratio of density of earth and moon is this, what is the radius of moon in terms of radius of earth? Simple. Simple question. I'll give you 2 minutes to answer it. So which option? Option A, B, C, D. Which one? 1, 2, 3, 4. Option number 1, 5 by 18. Yes, that is correct. What you got to do is you got to just put G in terms of density. We know this, yes or no? We just have to put the value of G in terms of density. With the value of G in terms of density, I have already given you the formula. It is 4 by 3 pi G rho into R. Yes or no?
Yes, sir.
So from there you can find out the ratio of acceleration due to gravity, G for E, write everything in terms of Earth, G for M, write everything in terms of Moon, and then divide them. Yes or no? Okay, then okay, this is the same question in a different way. Yes, this is, remember, this is these are the type of questions that have come in JEE. The faster you do, because I'll have to complete this acceleration due to gravity today. So the faster you do, the more questions I will do. Otherwise, I'll cut them short. If the radius of the Earth were to shrink by 1%, the mass remaining same, What is the effect on the acceleration due to gravity? That is why I gave you all those stuff. Yes. Yes, my dear friend. See, everyone is looking here and there. Answer is not here and there. Answer is right in your brain. Do it.
C, sir.
Huh?
Inc
A, B,
C.
C, D. Which one?
C, sir. Increase by 2%.
Increase by 2%. Chalo, Bhagwan. God is there. You see, I start questioning the presence of God. And this is the formula that you have to apply it. There was a negative sign. So if radius increases, gravity decreases, radius decreases, gravity, acceleration due to gravity increases. Yes or no? We understand this? Huh?
Yes, sir.
Next one, do it fast. If you do it fast, I will do more questions. If you don't do it fast, well, I'll say bye bye. Yeah, this is number 3. A planet has a mass 1/10 that of Earth, while its radius is 1/3 that of Earth. If the person can throw a stone on Earth vertically up to a height of 90 meters, how long will he, how high will he be able to throw on that planet? Yes, my dear friends. Any hope of an answer? Yes or no? No, yes. Huh? Chalo, I'll give you a minute. Yes, do I have an answer? Yes, what is the answer?
C, sir. 100
C,
meters.
sir, 100, sir. Okay, good. So how do you got to get to do this? Gm by r square. G is constant. So if I write G1 by G2 will be equal to M1 by M2 into R2 by R1 ka whole square. Yes or no? So
Yes.
I will have to find G on that planet. If G1 is G on Earth, I will have to find G on that planet. Yes or no?
Yes, sir.
So I have to find the value of G1 or G2 depending on which you call gravity on Earth. If I call gravity on Earth as G1, I will get G2 as 9 by 10 times of G. Yes or no?
Yes, sir.
Everyone got this? Now, once you get the value of G2, which is the acceleration due to gravity on that planet, you must just remember that maximum height h is equal to u square by 2g. Yes or no?
Yes, sir.
So h1 by h2 will be again equal to g2 by g1. Yes or no?
Yes, sir. Yes, sir.
So you can find out h2. H2 will be 10 by 9 multiplied by 90, and the final answer would be 100 meters. The only way you can make a mistake here is you take the wrong ratios. Instead of multiplying, you divide. Instead of dividing, you multiply. That is the only way you can make a mistake. Otherwise, these questions are halwa puri and everyone likes to have them. Halwa puri is a very famous cuisine of North India. It's like it's like idli dosa in the south of the country. Okay, next one. Do it fast, and I will move at the radii of two planets are R1 and R2. Densities are ρ1 and ρ2. What are the ratios of acceleration due to gravity? And the answer is The more the number of questions that you do,
D, sir. Row into
yes, so we have an
D,
answer.
sir.
It's a
D.
straightforward one. G1 by G2 is R1, row 1 is to R2, row 2. Yes or no?
Yes, sir.
The more the number of questions that you do, the better you are going to become. That finishes our this category of questions. Let us now move on to variation of G. How does G vary? Variations in the value of G. Variation in the value of G. How does and why does G vary? So number one case, A case here is due to the shape of earth. G varies because of the shape of earth. Why does G vary? Because of the shape of earth. Huh? Why does G vary? Because of the shape of earth. Why does G vary? Because of the shape of earth. Anyone? Why does G vary? Because of the shape of earth. No one knows. Remember, the earth is not a perfect sphere. It is in fact elliptical in shape. And this is how the shape is. It is more like an elliptical in shape. The radius at the poles is less than the radius of equator by around 21 kilometers. By around 21 kilometers, the radius is less. So if I write the value of G at equator, the value of G at equator will be Gm by Re square, where R is the radius of earth at the equator. If I write the value of G at the poles, it would be Gm by Rp square, where the radius is Rp. Do we understand this?
Yes.
So from here you can find out, and again I'm giving everything that is possible to you because the question can come from anything. So the ratio of these two G's will be Rp square divided by Re square. Are we getting this or not?
We are getting.
Okay, I'm also giving you the value. I don't think this value will come, but since I have gathered it, I will have to show you my talent. So this is how the difference is. The difference between pole and earth, pole and equator is 0.08 meter per second square. Whenever we are using the acceleration due to gravity 9.8, it is the value on poles 9.8. At equator, it is always going to be less. Do we understand this, or this has gone above our head saying bye bye, bye bye?
We understand, sir.
Okay. Everyone has noted this down? Yes or no? No, yes.
1 minute, sir. 1 minute.
1 minute, sir. Huh? Why, sir?
Done, sir.
Everyone has noted this?
Yes, sir.
Okay. Since everyone has noted this, we'll move on to the next thing. The point number B is due to height. Due to height above Earth. Now, as soon as you start going above the surface of the planet Earth, my dear friends, G also varies. Will it become less or will it become more? Tell me. Will it become less or will it become more? Will it become less or will it become more?
Decreases, so it will become less.
Well done. Where is the maximum value of G? Where is the maximum value of G? Due to Earth or any other planet? Where is the maximum value of G?
It's on the surface, sir.
It's on the surface. It's a gravitational field. It is maximum on the surface. Don't forget this. So if you move at a height h on the surface, the value of G is written as G. At a height h, it is written as G dash. Now it is very easy to understand that your original G is Gm by r square. Yes or no? No or yes?
Yes, sir.
But when you get to a height, your G becomes G dash. What will be the value of G dash? You can also write the same value in terms of G dash. So your G dash will become Gm by r plus h the whole square. Yes or no?
Yes, sir.
Yes or no? No or yes? Are we understanding this or this is going above our head saying bye bye?
We understand, sir.
Everyone is able to understand this?
Yes, sir.
Then I can write this new G at a height h in terms of the original G, and it will start to look like this. G dash will be equal to G into r divided by r plus h ka whole square. Yes or no?
Yes, sir.
Or you can also write it as, if you calculate the distance from the center of the earth, you can also write it as G into capital R square divided by small r square. Anyone understands this? Yes or no?
Yes, sir.
I hope there is no doubt on this.
No, sir.
Yes or no? No, yes.
Yes, sir.
Okay. Now remember important points. And we know most of these important points. As we go higher up, the value of G, will it decrease or will it increase? It will decrease, and it will decrease inversely with the r square. Yes or no?
Yes, sir.
If you go at a very large distance, then the value of G will become infinite.
Zero.
If you go at a very large distance, the value of G will become 0. Yes or no?
Yes, sir.
Then there is a very important formula, which is the formula which is valid when the height h is very small compared to Earth. If height h is very small compared to Earth, 1 kilometer, 2 kilometers, radius of Earth is 6400 kilometers. If the value of h is very small compared to Earth, the radius 1 kilometer, 2 kilometer, 5 kilometer, 10 kilometers, you can use this shortcut formula from binomial theorem. G dash will become G into 1 minus 2h by r. But remember, this formula is only valid, the pink formula is only valid when the value of h is very, very small compared to Earth. Do we understand this, the radius of Earth?
Yes, sir.
And again, I have seen questions based on the percentage of this change. What will the percentage change? This question may come as error wala question, or this may come in the case of gravitation. What is the percentage decrease? What is the absolute increase, absolute decrease? So absolute decrease becomes G minus G dash, fractional decrease becomes G minus G dash by D, and percentage decrease becomes multiplied by 100%. Do you understand how this is done? Simple math, nothing else. You understand this, yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. Let's move ahead and do this question. It's a question based on what we have learned. So let me call this question number 2. The acceleration of a body due to the attraction of Earth at a distance of 2r from the surface of Earth will be how much? Distance of 2r from the surface of Earth. Sometimes this distance is given from the surface of Earth. Sometimes this distance is given from the center of the Earth. So you must be very careful in reading the question where it is given. It is given at a distance of 2r from the surface of Earth. So remember this and get me the answer. I'm waiting for your answer.
Sir.
Yes, what is the answer?
A, sir. G by
A,
9.
sir, G by 9. You just have to put the formula. G dash is equal to G into R divided by R plus H the whole square. Yes or no?
Yes, sir.
Anyone understands this?
Yes, sir.
Yes or no?
Yes, sir.
Okay, so just put the values, get the answer, and stay happy. This is the next one. Yes, the height of a point vertically above the Earth's surface. When you say height of the point, it is from the Earth's surface, at which the acceleration due to gravity becomes 1% of its value. So acceleration due to gravity should become 1%. Question number 3. Of its value on the surface of Earth, at which point above Earth the value of acceleration due to gravity becomes 1/10, no, 1%, 1 by 100. Where does it become 1 by 100? Yes, do we have an answer?
1 minute.
This is such a difficult question, bacha. Okay, so shall I solve it? G dash is G into R upon R plus H ka whole square. What is the value of G dash? It should be 1%.
1%. Yes, sir.
It should be 1%. So it becomes G by 100 is equal to G into R upon R plus H. So things have gone from bad to worse. Anyways, life teaches you a lot of things. One thing is be patient. So G by 100 is G into R divided by R plus H ka whole square. From here you can find out the value of H beta. Yes or no?
Yes, sir.
What is the value of H?
9R.
See, it was so simple. Anyways, I hope you understand this. Yes or no? No, yes. Do you understand this? Yes or no?
Yes, sir.
Last question for today. Find the value of G at a height 64 kilometers from the surface of Earth. You must know the radius of Earth. What is the radius of Earth? Radius of Earth is 6400 kilometers. So, how will you find this one? Yes, tell me. How are you going to find this one? Which formula are you going to apply? G dash is equal to G into R by R
49
plus.
G by 50, sir.
Yes. You should not apply this formula. Which formula you should apply then?
Answer is 49 by 50 G,
G
sir.
dash into G 1 minus 2H by R. Do we understand this?
Yes, sir.
For small distances, you have to apply this formula. So G into 1 minus 2 into 64 divided by 6400. So this becomes 1 by 50. G into 1 minus 1 by 50. So it is 49 times G by 50. That is your answer in this case. Do we understand this? Yes or no?
Yes, sir.
Well done. So what we have done in today's class is we have seen that this acceleration due to gravity is nothing but the gravitational field produced by Earth. That is why we had used gravitational G as the symbol for gravitational field. We have seen how does G vary. We have seen G varies because of the shape of the radius is different. We have seen that G varies because of height. Two more things are left. Variation of G with depth. As you go inside the surface of Earth, G is also going to vary. Will it become more or will it become less? Inside the surface of Earth, is the G going to become more or going to become less?
More,
Huh?
sir. Will increase.
It is going to become less. At the center of Earth, what will be the value of G?
0.
It will be 0. So on the center of Earth, it is 0. On surface, it is maximum. And at infinity, it is again going to be 0. So we will see that variation of G with depth and also variation of G because of rotation of Earth. These are the two things that we'll see in the next class, that is tomorrow. And we will be finishing this and then we'll move on to the next thing, which is gravitational potential, which is the cousin brother of electrostatic potential. Whatever we are going to do this, we are going to repeat it 1 month from now. So take care. I'll see you in the next class. Bye bye. God bless all of you, beta.
Thank you, sir.